Hello everyone and welcome. In this session we will discuss on how MicroStation 2023 allows users to model anything, anywhere with geospatial context. We are excited to show you the new geospatial workflows and native integration with Esri ArcGIS REST Map and Image Service and Esri ArcGIS REST Feature Service, giving our users the ability to natively ingest geospatial data. You will learn how MicroStation 2023 brings new geospatial context features into the design process and help be efficient. Before we start, I have a disclaimer. So release plans and timelines are forward-looking estimates and projections only. There can be no assurance that Bentley will be able to meet such estimates or projections by the date specified or at all. Do not make purchases decisions based on forward-looking roadmaps. So my name is Louis-Martin Lausier and I'm a product manager of MicroStation. I have more than 15 years of experience in the geospatial industry. I've been working with Bentley systems for 5 years and it's been exciting working with the MicroStation team for the past year. My guest is Simon Hatch from AECOM. He's the Associate Director of Digital Engineering and BIM Data Integration. He has over 20 years of experience in dealing with digital construction information. His work is driven to establish and enhance ways to use BIM and add value to the construction projects. More recently, his team started working and managing Bentley iTwin service on a number of projects from a geospatial survey data context, producing and managing reality data. I'm really honored to have you with us today.
Thank you. It's a pleasure to be here.
Today we will be talking about geospatial context, the challenges, model anything, anywhere, the new workflow with user experience improvements, the repositories of open data and GIS services, and the business outcome. Could you tell us about your most recent project you're working on with Bentley software?
Yeah, sure. So recently we undertook a project in Scotland, in the UK, and Scotland's railway have an agenda to decarbonise the railways, so to look to work towards carbon neutrality and take diesel engines off of tracks and to electrify a lot of the existing railway infrastructure. And the project most recently I've been involved in has been from the central belt of Scotland up the east coast towards Aberdeen, and the image on the right hand side there shows an element of that route and an element of the iTwin service, the proposed design for electrification. So it's approximately 170 kilometers of railway that's looking to be electrified. So various terrains, various landscapes bring various challenges to the design on that project.
So what kind of data you need to start, design, and execute this project? How does AECOM often have GIS data on their projects?
Yeah, so we tend to use GIS particularly in the early stages, where we can either look to tap into open source GIS data, or a lot of the time our client may provide us with some GIS data sets to help us understand the local vernacular and the local surroundings of the project, to help inform designs moving forward. We'll also then carry out a number of on-site up-to-date surveys to collect various vector data as well as raster data to help commence the designs moving forward.
Thank you for the introduction of the Aberdeen and Central Belt Enhancement Project in bringing us to the data that you need for starting your design and planning process. So now let's do a deep dive in the geospatial context. Geospatial data related to a location on Earth like we see on this figure. There is two major types of data, the vector and the raster. As example here, the vector layers is represented for the administrative boundaries, streets, parcels. For the raster layers, land usage and elevation is represented by a grid. Vector data represent geographic data symbolized as points, lines, or polygons. Bringing the geospatial context referred to incorporating geographical information and spatial relationships into the design process. This involves integrating data related to the physical location and characteristic of objects within the design, often by using GIS data and geospatial data. So how important is the geographical location? Is significant factor in your projects?
It's crucial, yeah. So without understanding where the actual project is to take place, it's crucial that we set this up in the early stage and we establish a geographical coordinate system within that design, so that any design works moving forward are in real world coordinates, so that eventually when the design has been approved and the site teams actually go out and build the project, that they are specifying the correct location and the correct coordinate system. So that all starts at the very, very early stages of the project through the use of GIS data and geospatial survey data, but with various methods of survey to establish that.
Thanks for your insights about the significance of geographical location. You're spot on. Thanks. So we heard our customers and we understand that the geospatial context plays a crucial role in many design workflow, and we are committed to help our customers integrate this data effectively. We recognize that many of our customers face challenges when it comes to bring the geospatial context in their design. We believe that these challenges can be addressed through a user-centric product development, and we see a great opportunity to do discovery, learn, and bring the right solution to solve their problem. This is why we put in place an early access program, EAPs. We heard our user about their challenges and work around to bring the geospatial context. It is difficult for non-GIS MicroStation users to know what tool can access web geospatial context data. In previous releases of MicroStation, users needed to implement workarounds to view GIS data in their design applications. We did several discovery calls with our customer. Could you tell us more about these challenges, more specifically with the Aberdeen to Central Bell project?
Yeah, sure. So we were, the project team, design team was presented with a large amount of existing survey data that we could use on the project for the early stages of design. And one challenge that's previously been in place is the use of large survey data sets such as point clouds and sort of 3SM aerial survey reality meshes. But now with the advent of iTwin Capture and iTwin services, it's kind of revolutionized how we use that data a little bit, in the sense that, for an example, once upon a time we would have had to take a large point cloud and cut it up into, say, 5 to 10 gigabyte chunks to be able to import it into the authoring software, typically MicroStation. Whereas now iTwin Capture will host large data sets, and we're using sort of 80 to 100 gigabyte files now, which we stream into design authoring software rather than importing it. So it's located in the cloud and we stream it, and it's much more fluid. So that saves a lot of time having to manage that particular survey data and not having to carve it up anymore into usable chunks. And that tends to be the same for the aerial survey reality data as well, the 3SM meshes that we export from Bentley Context Capture. So it's kind of revolutionized the way we utilize our survey data. And with the advent of Bing Maps mapping service in the background, it brings the whole survey data into a much more contextual environment for the design team to understand.
So a strong grasp of geospatial context offers solutions to a range of challenges that can emerge during a project development. So that's really crucial for you. So like I mentioned about the early access program, our goal with the EAPs is to validate early on and get user feedback before the commercial release of MicroStation. So we validate that we are on the track. So these are some of the quotes that we received from our early adopters. So MicroStation is the best for Bentley design ecosystem. It is the foundation that supports the entire Bentley modeling ecosystem. So how geospatial context is important for AECOM in its project lifecycle, and how you envision geospatial context enhancing the initial site selection and planning stages.
Yeah, sure. So previously we've utilized GIS data in a typical GIS environment, I guess, in a possibly in a more siloed manner. And with the advent of the new tools within the power products and MicroStation, the new ribbon, etc., is going to make it so much easier for a CAD user to utilize GIS data, which has never really been established before. I think typically the industry has CAD technicians and CAD personnel that deal with vectorized CAD data, and then there is geospatial GIS technicians that deal with a lot of GIS and raster data. So we're bridging the gap quite a lot, I think, moving forward. And it's going to be really interesting to allow CAD technicians, etc., and designers utilizing MicroStation to be able to access GIS data in a much more usable format, like they've never been able to do before.
Good to hear that this will make life easier for CAD users and that we are bridging the gap to bring you more efficiency during your design and modeling phases. Thanks for adding this. So what model anything anywhere means? It means that all the infrastructure geometry should be created linked to the context. So to do that with MicroStation, you can model anywhere by georeferencing the data and working in a real-world context, connecting with the most used maps, raster, and GIS services. So here's a short video showing the new geospatial context workflow. A new workflow brings together all the tools for accessing contextual data from the web. Support for Esri REST map and image service allows you to dynamically display raster data from an Esri web service. This data is displayed with Raster Manager MicroStation imaging engine. Connecting to the Esri ArcGIS REST feature service allows to query features from the service and create a DGN representation of the feature in the active model. The feature attributes are also queried and saved as item type in the DGN elements. So what includes in the new geospatial context workflow? So we can see here there's a tool from Geographic to assign the coordinate system and display Big Map. These two already exist in MicroStation, but we brought them together in the new workflow so you can find it easier. So Bing Maps data is generic and widely used public map. So we also have in the ribbon a feature services. This is the Esri ArcGIS feature service for this and the Open Geospatial Consortium OGC web feature service. So you can view data, edit data locally, and search data. This is the vector data. It's published from either server created by organizations. So many owner-operators have their own GIS server, or data can be published from open data or open access or governmental organization. And we also have the ribbon, the raster services. So the Esri ArcGIS map and image service and the OGC WMS and WNCS. So in this release, only the basic security using username and password is available. In future release, support secure dataset with enhanced sign-on authentication will be added. Public server from open data does not require any credentials. So adding Bing Maps as background map provides a visual representation of the geographic context in which your design or data is located. This context is essential for understanding how your project interacts with its surroundings. How you locate your project in real coordinates, Simon?
Yeah, okay. So we would start with a site survey of some description, and we would look to set up some sort of survey control network, and we would understand what the geographical coordinate system needs to be, and then use taking GNSS coordinates or GPS coordinates and transpose them into a DGN file while setting the geographical coordinate system in that DGN file to create the relevant templates for the design to commence. And then we would, we cross-reference that with the survey report that may have been produced, that should have been produced, to ensure that all the checks and assurances are done prior to any design taking place.
Okay, understand. So Bing Maps data can only be displayed in a model that has a geographic coordinate system. So choosing yes automatically opens the geographic coordinate system dialog to allow the selection of the desired geographic coordinate system. So using this tool, you can see that the operation has to be redone for each view. And with this new tool, it's now possible to change the display of Bing Maps for several views in a single operation. The Esri REST feature service provides access to a vector representation of each feature stored on the server. The direct integration of the Esri ArcGIS REST feature service saves time by avoiding having to go through an intermediate format such as the shapefile. MicroStation feature service support allows the user to query the server and create copies of the features in the active model. If an entity is modified on the server, its local copy will not automatically be updated. It will be updated by the next time the query tool is run by the user. These elements are seen as read-only by MicroStation tools. The special clear features tool should be used to remove the queried features from the model. To include any of these features in their design, the user must pick up a copy that will be disconnected from the feature service. Connecting to the Esri ArcGIS REST feature service allows to query features from the service and create a DGN representation of the features in the active model. The connection name is automatically initialized with the name of the Esri feature service. This name can be edited by the user. When using a query feature tool, only features that overlap the extent of the active view are created. For each feature, a DGN element is created and placed on the level generated by appending the connection name and add the layer name. Since the imported features have been placed on a dedicated level, it is possible to stop their display by deactivating the display of this level. Graphical attributes such as color and line weight are also read from the server and used when creating DGN elements. Finally, non-graphical information, commonly called business properties, are also read and saved in item types linked to the DGN elements. The Esri REST map service provides live imagery data that is displayed through the MicroStation engine. The data displayed comes from a map that has been defined in the Esri environment and shared by their REST service. The integration of the Esri ArcGIS REST map service in MicroStation make it possible to display these maps as they were created, and they are displayed via raster manager like other raster data. Support for your Esri REST map and image services allow you to dynamically display raster data from an Esri web service. This data is displayed with Raster Manager MicroStation imaging engine. Many Esri map services allow the user to select the desired layers. In this case, we only select the layer Philadelphia Street Centerline 2022. Since Esri map services data is displayed as an image through Raster Manager, it is possible to control the display through Raster Manager. In this example, we disable the display of data in View 2. The new geospatial context workflows support OGC standards, as we find important to define what is OGC. The Open Geospatial Consortium, OGC, is an international standards organization that develops and promotes open standards for geospatial location-based technologies. OGC is the leading international organization for coordinating standards related to geospatial information. We also support some of the OGC standards, like the Web Map Service (WMS) and the Web Map Tile Service (WMTS) and the Web Feature Service (WFS). This last one, WFS, is available in MicroStation 2023.1. So let's look at the integration with the OGC Web Feature Service. Much as Esri Service Integration feature, accessing OGC directly from the geospatial environment is convenient. Contextual data is important when designing to consider the environment in which infrastructure will be built. The direct integration of a well-known OGC standard web feature service creates DGN elements with business properties ready to use in the design workflows. MicroStation will now be able to connect read-only to OGC web feature services. With this connection, users will be able to query the server and create DGN elements, including the values of its semantic properties, item types. Connecting to the OGC WFS feature services allow to query features from the service and create DGN representation of the features in the active model. These are the same tools used for connecting and manipulating Esri feature and WFS services. It is the application that takes care of communicating with the server as it should, depending on the tip of the ladder. Since WFS servers do not have a name specified in their GET capabilities, the automatically generate name for the connection is taken from its URL. The user can give it a personalized name if he wishes to simplify it. Graphical attributes such as colors could be changed. The feature attributes are also queried and saved as item type in the GGN elements. Simon, could you tell us about the benefits you see that could help your team solve some of these challenges you mentioned at the beginning of the presentation?
Yeah, sure. So being able to stream in this type of data um, without almost having to look for it presents big benefits in data management, and it will save a substantial amount of time. If the data is all sort of held in one or two repositories and not on sort of local hard drives or local servers, then it's taken away the risk of human error looking for this data. So if it's streamed in from automatically from its source, and the user doesn't have to sort of go away and look for that source, then that's a huge benefit to our operatives and our design teams moving forward. There's much less risk of human error and much less risk of using the wrong type of data that may well be out of date.
Thank you for giving us this overview of the benefits. With the new workflow geospatial context, it is good to be able to connect to these services. But like we mentioned at the beginning, geospatial data integration is often the first step in a civil design project. Open data is more and more used and offered by government and organizations. If you don't have data, where can you start? There are several open data repositories where you can find datasets suitable for use with Esri services and OGC services. These repositories offer a wide range of geospatial data that can be utilized for various purposes, including infrastructure projects, but it's important to remember that you need to validate the quality of the dataset you use. Could it help reduce some of your project costs?
Yeah, absolutely. I think it could help reduce costs by potentially streamlining the overall project program. And if our operatives can access data much quicker without, as sort of previously alluded to, without having to go away and actually look for it, there's a substantial time saving there. And if we're saving on time on a program, then generally we're saving on money. So there'll be project cost savings to be had there. How we quantify that is a difficult quantification to establish, but a lot of it will depend on the size of the project, and it'll help streamline and being able to stream data in from web-enabled services is taking away a big headache for a designer or a user. They don't necessarily want to have to go away and look for that information. They just want it readily available, if that makes sense. So not only is it making it easier, but it's also saving time and therefore saving money.
Yeah, it makes total sense. So we see that open data could help starting a project from scratch and saving you some time. So why geospatial context is important? With a better geospatial integration and interoperability, user can view design and geospatial context in a single environment. Their maps can be added as contextual information in the background. They save time previously required the use of one or many intermediate files. They will be able to use the same graphical representation as defined in the Esri server. It will improve collaboration among different departments contributing to the same project. And last, it will enhance visualization functionality. So like we discussed, adding the ability to stream geospatial context in the design tools is important and will help our users so they don't have to handle any movement of the GIS data. So based on your experience with digital construction, do you see a potential for wider adoption of geospatial data in your organization construction projects?
Yeah, completely. I think that there'll be a big requirement for it as we move from the capital phase delivery of a project to the operational phase of the life cycle of the project. And a lot of asset managers and asset maintainers need to understand what data they have and how up to date it is regarding their particular asset, whether it be a built asset or a linear asset, for example. Linear assets, like built assets, are very challenging. There's a number of works going on at various times throughout the project life cycle. So that geospatial data needs to be almost constantly updated as and when the project itself is updated. So how we manage that data moving forward is absolutely crucial. So having an understanding of how old that data is, when it was gathered, to what level of accuracy the data is very, very crucial. And I think asset maintainers will embrace more geospatial data, the more it's more made freely usable for them. Through things like web-enabled services, etc.
Thank you for elaborating on the benefits of incorporating this geospatial data into digital construction process. So before we conclude, I will take a moment to thank our guest Simon for his participation in this session and for highlighting some of the key elements of their project. Thank you for sharing your insights on how geospatial context is crucial, and also for contributing in the advancement of the digital construction. Thank you everyone for attending this session. If you have any questions, feel free to reach out to our team.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.